Select the pin type, shackle type and suspension type insulators. Fasten jumper in cross arm of pole with pin insulator. Fasten the jumper in shackle type insulator. Fasten the jumper in suspension type insulator. Electrician toolkit and equipments required. Insulated combination plier 200 mm. DE double-ended spanner set 6 mm to 25 mm. Adjustable spanner 25 mm. Wooden or nylon mallet half kg. Ladder 6 meters long. Wire stripper 150 mm. Suspension type insulators, pin type insulators, binding wire 14 SWG aluminium 5 meters. ACSR conductor as required. Safety belt and rope, clamp, nut and bolt, shackle type insulator, pin type insulator. Before getting into the practice, let us know some basic information on pin, shackle and suspension type insulators. Pin insulators are used for holding the line conductors on straight running of poles. It is secured to cross arm on the pole. There is a groove on the top of the insulator for housing the conductor. These are used in LT lines. Shackle insulators. Shackle insulators are generally used for terminating on corner poles. These insulators are used in overhead lines for low and medium voltage lines only. These insulators are used in both horizontal position and vertical position. Suspension type insulators. Suspension type insulators are used with steel towers for HT lines. They consist of a number of porcelain discs connected in series by metal links in the form of a string. Each disc is designed for a low voltage of 11 kilovolts. The suspension provides greater flexibility to the line. Now let us start our exercise. Now we are going to practice our first task, that is, fasten the jumper in pin insulator. Check the tools and materials for their good condition. First, place the ladder on the pole and ask a helper to hold the ladder. Fasten the safety belt and climb up on the ladder with the guide rope and spanner set. Position yourself and tie the safety belt with the cross arm. Drop one end of the guide rope down and ask the helper to tie the pin insulator assembly to the rope end. Lift the rope up with pin insulator assembly. Fix the pin insulator assembly to the cross arm. Lift the ACSR conductor, that is, aluminium conductor steel reinforced, from the ground with the help of guide rope. Place the ACSR conductor between the pole and the pin insulator. Place the ACSR conductor in the slot provided on the top of the pin insulator and ask the helper to stretch the conductor with the help of a wire stripper. Take about 2 meter long binding wire and hold from the middle. Bind a minimum of 2 turns around the pin insulator neck. Make a tight knot on the neck of the insulator with the free ends of the binding wire. Wrap both ends of the binding wire tightly over the line conductor on both sides of the pin insulator and in opposite turns to each other. Bind the binding wire on the neck of the insulator if the deviation or bend comes on the conductor. Bind the wire tight enough without any gap and finish it after giving about 15 turns on both sides. Cut the extra wire and round off the raised ends around the conductor. After finishing the work properly, get down from the pole safely. Our second task is to fasten the jumper in shackle insulator. Check the tools and materials for their good condition. Place the ladder on the pole and ask the helper to hold the ladder. Fasten the safety belt and climb up on the ladder with the guide rope and spanner set. Position yourself and tie the safety belt with the cross arm. Drop one end of the guide rope down and ask the helper to tie the shackle insulator assembly and C-clamp to the rope end. Lift the rope up with the insulator assembly. Fix the shackle insulator over the cross arm with the help of C-clamp. Make the loop of the conductor around the groove of the shackle insulator and leave about half a meter free end. Take the 14 SWG aluminium binding wire and bind the line conductor and free the end together tightly without any gap with loop around the insulator up to the length of about 100 to 150 mm as shown. Complete the required turns of binding wire and twist the extra free end of the conductor towards the insulator. After finishing the work properly, get down from the pole safely. Our third task is fasten the jumper in suspension type insulator. Check the tools and materials for its good condition. Place the ladder on the pole and ask a helper to hold the ladder. Fasten the safety belt and climb up on the ladder with the guide rope and spanner set. Get the suspension insulator assembly from the helper with the help of the guide rope and fix it to the cross arm on the pole. Lift the ACSR conductor, that is aluminium conductor steel reinforced, from the ground with the help of guide rope. Drop down one end of the guide rope and ask the helper to tie the conductor properly with the rope and carefully lift the conductor up to cross arm. Arrange the conductor properly between the two clamps provided in the insulator assembly and fix the conductor by tightening the bolt and nut of the clamps securely. Take 14 SWG aluminium binding wire and bind the conductor with the insulator assembly tightly without any gap. After finishing the work properly, get down from the pole safely. Recap. In this session, we have learned how to select the pin type, shackle type and suspension type insulators. Fasten jumper in cross arm of pole with pin insulator. Fasten the jumper in shackle type insulator. Fasten the jumper in suspension type insulator. We must carry out these process with utmost care and safety precautions. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session of Electrician Trade. Today, we are going to see how to erect an overhead service line pole for single phase 240 volts distribution system in open space. At the end of this session, you will be able to select the type of pole to be erected, fix the cross arm on the pole, select the place to erect the pole, dig the pit and erect the pole. Electrician toolkit and equipments required. DE double-ended spanner set 6 mm to 32 mm. Combination pliers 200 mm. Heavy duty screwdriver 300 mm. Safety belt. Crowbar 2 meters long, 40 mm diameter. Spade, shovel, plumb bob with thread. Jute rope 15 meters long. Hammer ball pin 500 grams. Bamboo ladder. Draw pulley. Aligning rod. Wooden or RCC or iron or tubular pole 6 meters length. MS angle iron cross arm. C-clamp MS size as required with nuts, bolts and washers. Country wood plank 2 meters long, 30 cm width, 5 cm thick. Cement, sand, blue metal chips etc. as per the size of pit. Stay insulators 2 numbers. Double screw stay tightener 2 numbers. CI cast iron stay plate, 2 numbers. Stay rod, 2 numbers. Steel wire, 16 meters. 15 into 12 mm size MS bolts with nuts and washers. Base plate for pole, 2 numbers. Casuarina pole of suitable height, 4 numbers. Wooden box of suitable size, 1 number. Before getting into practice, let us have a brief look at overhead power lines and the type of poles and towers. In electric power transmission and distribution, mainly overhead power lines are used to transmit electrical energy at propensity to decay below the ground. Have a shorter lifespan, say 20 to 25 years only. Cannot be used for voltages higher than 20 kilovolts. Have lower mechanical strength. Need routine inspections. Steel poles. Steel poles are more durable, have longer lives and enable the usage of longer spans. There are 3 different kinds of steel poles: rail poles, tubular poles and rolled steel joint. It needs to be galvanized or painted in order to prolong its life. RCC poles. RCC poles are reinforced cement concrete poles with greater mechanical strength, longer lifespans and are used for longer spans. They need minimal maintenance and have good insulating properties. Steel towers. Steel towers are used for long distance transmission at high voltages. They have greater mechanical strength, longer life and can withstand more severe climatic conditions. Fixing cross arm on the pole. Cross arms are installed at the top of the pole for holding the insulators on which conductors are fastened. Cross arms are made of either wood or angle iron. They are also known as insulator supports. U-shaped cross arms are specially used for 3-phase lines. Now let us start our exercise. First of all, select the suitable place for standing pole as per the span of line. Select the type of pole to be erected. Dig a pit for the pole to be erected. The depth of the foundation setting is dependent upon the density of the soil, depth of frost penetration and structure of the earth. Dig a pit about 1/6 height of the pole having a diameter of minimum 3 times that of the diameter of the pole bottom. Prepare a mixture of concrete having a ratio 1:2:4 as 1 part cement, 2 parts coarse sand and 4 parts 2 cm blue metal chips and pour the same in the bottom of the pit to a height of 15 centimeters. Leave the concrete and allow it to settle for a minimum period of 48 hours. Fix the base plate to the bottom of the pit. Place the straight pole on the plumb line of the pit and bring the pole near the pit so that the bottom of the pole is at the edge of the pit. Fix a wooden plank inside the pit vertically so that the base of the pole faces towards one side of the pit. Fix the cross arms on the top of the pole below 30 centimeters from top with the help of C-clamps rigidly. Tie 2 ropes just below the cross arms. Place the casuarina pole at a distance of 1/3 height from the top and bottom. Prepare the concrete mixture in the ratio 1:3:4 as 1 part of cement, 3 parts of sand and 4 parts of 1 cm blue metal chips. Lift the poles step by step with the help of cross arm ropes and casuarina poles and place it on the pit exactly in the vertical position by using plumb bob and aligning rod. Pour the concrete mixture into the pit around the pole. Place the wooden box around the pole and pour the concrete mixture into the box to a height of 0.5 meters above the ground level. Leave the concrete for about 48 hours. Remove the wooden box and plaster the concrete above the ground level to have a smooth finish. Fix the stay rod to the ground away from the pole so that the stay wire gets 45 degrees to 60 degrees angle to the ground level. Cut the stay wire into 2 pieces of the required length and fix each end of the stay wire to a strain insulator. Fix other end of the stay wire to the stay rod and tighten them with the help of a thimble. Fix and tighten the stay tightener nut until there is no sag in the stay wire. We must carry out the process with utmost care and safety precautions. Recap. In this session, we have learnt how to select the type of pole to be erected. Fix the cross arm on the pole. Select the place to erect the pole. Dig the pit and erect the pole. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session of Electrician Trade. Today, we are going to see practice on laying of domestic service line. At the end of this session, you will be able to locate the nearest pole, specify and estimate the quantity of materials required, prepare the GI pipe, bend in the form of a gooseneck and install it in position. Prepare the support GI wire with ring insulator as separators and service cable. Draw the service cable and connect it to the energy meter. Connect the service cable to the overhead line through an aerial fuse. Earth the service cable support wire at both ends. Electrician tool kit and equipments required. Electrician tool kit. Pipe jumper 25 mm diameter, 40 cm length. Pipe wrench 50 mm. Megger 500 volts. Ravel plug tool number 10 with bit. Hacksaw adjustable with blade 300 mm. Safety belt. Bamboo ladder 6 meters height. GI die set with stock 15 to 40 mm. Earth clips 40 mm 6 numbers. Twin core service cable weatherproof or PVC sheathed insulated cable 2.5 square mm 250 volts grade. GI wire 10 SWG. GI wire 12 SWG and 22 SWG. GI wire 7x3 into 15 mm size. Porcelain ring insulator 70 numbers. GI pipe 40 mm 3 meters. GI bends 40 mm. MS clamps 40 mm 3 mm thick. Wood screws 40 mm number 8. 8 numbers. Silver paint 200 ml. Stay insulators 2 numbers. Bombay nails 8 numbers. Cable glands, bricks, sand, cable compound, solder, clamps for fixing the cable as required. Locate the nearest pole, specify and estimate the quantity of materials required. In the electrical power distribution system, the service connections from an existing service pole to the consumer building will be provided by service lines. When working on a service line, it is of utmost necessary to make a shutdown before connecting the service cable to the service line. Now, let us start our exercise. Locate the nearest electrical pole and measure the distance from the pole to the building to which the service line is to be drawn. Note down the measured value in the tabulation. Identify whether the supply required for the house is single or three-phase. Note, care should be taken to see that the service cable does not cross the adjacent building area. Prepare the GI pipe, bend in the form of a gooseneck and install it in position. Now, locate the position of the meter board and determine the height of GI pipe to be fixed for service connection. Determine the length required for the gooseneck bend and the thickness of the wall. Note down the measured value in the tabulation. Determine the length of the cable required from the inside wall to the meter terminals. Note down the measured value in the tabulation. Calculate the required length of service cable and GI pipe from the measured values. Mark and cut two pieces of GI pipe of length L1 and L2. Thread the GI pipe of length L1 and L2 at one end. Bend one end of the longer GI pipe L1 to form the gooseneck having a diameter equal to 12 times of the pipe diameter. Make a hole in the wall with a pipe jumper such that the pipe where fitted is nearer to the energy meter terminals. Fix the GI bend to L2 GI pipe. Prepare the support of GI wire with separators and service cables. Pass the fish wire through the assembled pipe. Fix the GI pipe vertically to the wall using MS clamps. Bind two numbers of small ring insulators in the case of single phase supply in one set by means of a suitable GI wire of 10 SWG. Bind such sets at a uniform distance to a main support GI wire of 10 SWG. Pass the service wire through the ring insulators, leaving a sufficient length of wire for connection at both the ends. Mark the cables as phase and neutral at both ends. Fix one end of the support GI wire to the vertical pipe below the gooseneck using U clamps. Fix the other end of the support GI wire to the pole. Draw the service cable and connect it to the energy meter. Draw the service cable through the GI pipe by fish wire, providing bushes at both the ends of the pipe. Connect service cable to the overhead lines through an aerial fuse. Connect the service lines to the energy meter and then to the cutouts. Earth the service cable support wire at both ends. Connect an earth continuity conductor between the U-clamp of GI pipe and to the consumer main board earth terminal. Provide earth clamps on the GI pipe for earthing. Connect the phase cable of the service cable to the phase wire of the distribution line through a joint or by a connector. Connect the neutral cable of the service cable to the neutral wire of the distribution line through a joint or by a connector. When working on a service line, it is of utmost necessary to make a shutdown before connecting the service cable to the service line. Inspect the service line connections and then energize the line. Recap. In this session, we have learned how to locate the nearest pole, specify and estimate the quantity of materials required. Prepare the GI pipe, bend in the form of a gooseneck and install it in position. Prepare the support GI wire with ring insulator as separators and service cable. Draw the service cable and connect it to the energy meter. Connect the service cable to the overhead lines through an aerial fuse. Earth the service cable support wire at both the ends. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session of Electrician Trade. Today, we are going to see how to install bus bar and bus coupler on LT line. At the end of this session, you will be able to determine the location for installing bus bar and select the bus bar with bus coupler. Mount and fix the bus bar. Insert the plug-in boxes in the bus bar system and also bus coupler. Test for earth continuity of bus bar and for insulation resistance. Electrician toolkit and equipments required. Electrician toolkit: DE spanner set 6 mm to 25 mm, crimping toolkit, ladder with adjustable height, high stool, hand hacksaw frame, megger, bus bar of available current rating and standard length, current rating, plug-in boxes 32 amperes, bus bar brackets, MS flat for suspending the bus bar or GI pipe for supports and all supporting accessories, nut and bolt size and quantity of extension standard accessories, bus coupler. Determine the location for installing bus bar and select the bus bar with bus coupler. In the industrial workshops and factories, a number of machines are installed on the shop floor closely but apart from each other. Connecting these machines to electrical supply through underground cables or overhead wires may involve cumbersome methods resulting in shock hazards. The main function of the bus bar is to connect the number of service lines electrically which are operating at same voltage. Bus bars are made of copper or aluminium conducting material. They are either in the form of flat strips, solid bars, or tubes. There are different types of bus bars: single bus bar system, sectionized single bus bar system, duplicate bus bar system, double bus bar with 2 circuit breakers. Advantages of bus bar system: bus bar reduce system costs. Bus bars fabrications allow flexibility. Bus bars improve reliability. Laminated bus bar increase capacitance. Bus bar eliminate wiring errors. Bus bars provide wider variety of interconnection methods. Mount and fix the bus bar. Let us now start our exercise. First of all, trace the workshop layout and calculate the total capacity and rating of electrical machines and main power supply at entry point. Determine the required length of bus bar by the layout. Identify the support structure required to lay the bus bar by the site inspection. Mount and fix the bus bars to the supporting structure. Insert the plug-in boxes in the bus bar system and also the bus coupler. Insert the plug-in boxes into the plug-in points. Plug-in boxes are compact sheet steel boxes with hinged doors housing the HRC fuse holders, which are solidly connected to high conductivity copper clip on contacts reinforced by spring steel strips. These clips on contact plug directly to the bus bars at the plug-in points. 2 earth pins are located at the 2 ends of these boxes, which also serves to mount the plug-in boxes on bus bar. Couple the new bus bar mechanically and electrically by using a bus coupler if another length is needed. Tight and secure the bus bar with screws locking plates. Terminate the plug-in boxes to the loads through metal conduit runs and suitable cables. Test for earth continuity of bus bar and for insulation resistance. Test the bus bar system for earth continuity. Earth continuity test with lamp. On control panel, bus bar should not have any supply. Take one test lamp of 230 volts by 100 watt rating. In this, one lead to be connected at the supply point P phase and another lead of the lamp to be connected at bus bar control panel earth point, that is earth terminal. If lamp glows brightly, the bus bar control panel earth is good. If the lamp does not glow, assume that the bus bar control panel was not earthed, which means open. Test the system for continuity and insulations. Connect the bus bar to the incoming supply cable with trifurcating box after conducting all tests and ascertaining test results are OK. Recap. In this session, we have learnt how to determine the location for installing bus bar and select the bus bar with bus coupler, mount and fix the bus bar, insert the plug-in boxes in the bus bar system and also bus coupler, test for earth continuity of bus bar and for insulation resistance. We must carry out these processes with utmost care and safety precautions. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session of Electrician Trade. In this session, we will learn about identify various parts of relay and ascertain the operation. At the end of this session, you will be able to identify the external controls and parts of an electromagnetic relay. Identify the internal parts of a single pole overcurrent relay. Ascertain the operation of the relay. Electrician toolkit and equipments required. Electrician toolkit, multimeter, electromagnetic relay, 12 volts DC, single pole overcurrent per earth fault relay with instruction manual. Safety precautions. Once the relay is stripped, the flag will indicate a red line, and once it is stripped off, it needs manual resetting by operation of the lever. Do not allow any dust or tiny particles to enter inside the relay. Dust will deposit in the pinion and affect the disc movement. Do not touch or try to operate any projected parts inside the relay. Multimeter. Caution: while using multimeter, select proper mode of selector switch for voltage, current and resistance, and also choose proper range. Never use cable of small size for relay connection, otherwise a tripping fault may occur. Let the relay be cooled for about 10 minutes after each test. Connect the relay parts carefully. Identify the external controls and parts of an electromagnetic relay. Time multiplier setting. The multiplier determines the time delay period of the relay's operation in relation to the nominal operating time to select the desired time setting feature. It is typically represented as a numerical value or a dial setting. Trip flag. It is a signal or indication that the relay has tripped or been activated. It is often used to alert operators or monitoring systems about the status of the relay, particularly when it has detected a fault or abnormal condition in an electrical circuit. Aluminium rotating disc. The disc spindle carries a moving contact which bridges two fixed contacts when the disc has rotated through a preset angle. The angle can be set to any value between 0 degrees and 360 degrees and thereby giving desired time setting. Percentage fault quantity time reference dial. Tap setting plug. The tapping are connected to a plug setting bridge by which the number of turns in use can be adjusted, thereby giving the desired current setting. The plug bridge is usually arranged to give 7 sections of tappings to give over current range from 50% to 200% in steps of 25%. Input fault quantity. It expresses load current. Contact plug terminals. These are trip contact circuit terminals. Note down the tap setting of current ranges in the table. Note down in table the indications displayed in the dial, multiplier along with percentage of fault current and trip timing. Locate the tripping flag indicator resetting level provided in front panel. Once the relay is tripped, the flag will indicate a red line. Once it is tripped, it needs manual resetting by operating the lever. When the tap setting is set at 0.25 amperes and PSM is set at 3, the multiplier of fault current is 7.5 amperes and the time in seconds is at 18. Will trip? See the calculation. Similarly, when the PSM is 4, the fault current is 10 amperes and the time in seconds is at 10.5. Will trip? Similarly, when the PSM is set at 6, the multiplier of fault current is 15 amperes and time in seconds is at 8.5. Will trip? Identify the internal parts of a single pole overcurrent relay. Loose the 4 knobs locating on the corner of the relay and remove the front cover of the relay. Keep the front cover and knobs at the safe place. Identify the aluminium disc fitted in the bottom of the spindle and time multiplier setting disc fitted on the top of the spindle of the relay. Locate the divisions marked on the time multiplier setting disc which is used for time setting and identify the spiral spring mounted on the top of the spindle which is used for bringing back the disc top to its original position after tripping. Identify moving contact fitted with the spindle on the top of the disc which is used to enable the tripping circuit and 2 terminal contact points which are used to switch to trip circuit. Record the readings. Assemble front panel of the relay. Internal parts and functions of a single pole overcurrent relay. Aluminium disc. The disc spindle carries a moving contact which bridges 2 fixed contacts when the disc has rotated through a preset angle. The angle can be set to any value between 0 degrees and 360 degrees and thereby giving desired time setting. Upper electromagnet. The upper electromagnet has 2 windings. One of these primary and is connected to the secondary of the current transformer. Secondary winding. Secondary winding is connected to the primary winding line. Lower electromagnet. Below the aluminium disc. Plug bridge. The tappings are connected to a plug setting bridge by which the number of turns in use can be adjusted. Primary winding. These are the part of pickup current coils. Trip circuit. At these terminals, tripping circuitry will be connected. Ascertain the operation of the relay. Connect the electromagnetic relay as shown in the figure to the circuit which is to be on or off automatically. Connect the circuit to the power supply and increase the supply gradually. As the current flowing in the circuit reaches the rated value of the circuit, the electromagnet of the relay excites completely. Then, the electromagnet attracts the iron core so that the NO or NC contact switch on or off the external circuit connected to it. Read and record the tripping current of the relay. Reduce the supply gradually to 0 and disconnect the power. Note: at rated current of 200 milliamperes, excited the relay, while decreasing the voltage to 9 volts or current to 120 milliamperes, insufficient of the coil current, the relay coil makes chattering. So, it is not fully stable or unstable condition. Recap. In this session, we have learnt the external controls and parts of an electromagnetic relay, the internal parts of a single pole overcurrent relay. Ascertain the operation of the relay. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session of Electrician Trade. In this session, we will learn about practice setting of pickup current and time setting multiplier for relay operation. At the end of this session, you will be able to calculate the fault current in different percentages, set up current in injector unit for different fault current, set the pickup current of a 50% fault current, set the time multiplier for time setting under various fault conditions. Electrician tools kit and equipments required. Electrician tool kit, overcurrent relay with manual, current injection unit with manual, air circuit breaker, 3-phase, 415 volts, maximum capacity, 400 amperes with instruction manual. Multimeter. Caution: while using multimeter, select proper mode of selector switch for voltage, current and resistance, and also choose proper range. Safety precautions. Once the relay is stripped, the flag will indicate a red line, and once it is stripped off, it needs manual resetting operation of the lever. Do not allow any dust or tiny particles to enter inside the relay. Dust will deposit in the pinion and affect the disc movement. Do not touch or try to operate any projected parts inside the relay. Never use cable of small size for relay connection, otherwise a tripping fault may occur. Connect the relay parts carefully. Let the relay be cooled for about 10 minutes after each test. Calculate the fault current in different percentages. Determine the value of supply current at which the operating overcurrent trips the coil of the relay. Identify the input current terminals and shorting pins of NC or NO contacts of the relay. The current injector unit is required to provide different fault current levels. The fault current settings is done in tap setting provided in the relay along with percentage of fault current with time. According to the manual instructions, the connections of tripping coil voltage and fault current from the current injector to the relay. Keep all the controls of the current injector unit at 0 position. Before going to practical, to know the introduction about current carrying capacity of the conductor, the current carrying capacity of an conductor or cable is the maximum current, that is, the number of amperes that it can continuously carry without exceeding its temperature rating. It is also known as ampacity. It depends upon the major factors such as conductor size, ambient temperature, insulation conditions. Now, we will see a small calculation for current capacity of the copper cable up to 30 square mm. The equation is 6 into cable size. For example, 6 multiplied by 1 square mm is equal to 6 amperes. The 6 amperes is the maximum carrying capacity of that conductor. Set up the current in injector unit for different fault currents. Adjust the tap of relay and set it for 1 ampere. Determine the multiplier from the dial. Note down the values. Select multiplier 2 so that the total fault current is 2 amperes and ensure that the time multiplier disc kept at position 1. Record the corresponding time shown in the dial of multiplier 2. On the current injector unit, observe that the relay is energized and increase the input current of the relay gradually to the pickup current. The disc of the relay starts to move as the current increases to pick up values. Record these values. Set the pickup current of a 50% fault current. It may be noted that when the TMS set for 0.5, the actual trip time is reduced by 50% of the trip time actual. Set the time multiplier for time setting under various fault conditions. Set all the control switches or knobs of relay at 0 positions. Rotate the TMS disc located on the main spindle and set at the position of 0.5. Determine the multiplier from the dial. Note down the values. Select multiplier 2 so that the total fault current is 2 amperes and ensure that the time multiplier disc kept at position 1. Record the corresponding time shown in the dial of multiplier 2. On the current injector unit, observe that the relay is energized and increase the input current of the relay gradually to the pickup current. The disc of the relay starts to move as the current increases to pick up values. Record these values. Recap. In this session, we have learned how to calculate the fault current in different percentage. Set up current in injector unit for different fault current. Set the pickup current of a 50% fault current. Set the time multiplier for time setting under various fault condition. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session of Electrician Trade. In this session, we will learn about identify the parts of circuit breaker, check its operation. At the end of this session, you will be able to identify the external parts of air circuit breaker, identify the internal parts of air circuit breaker, test the manual tripping of air circuit breaker. Electrician toolkit and equipments required. Electrician toolkit, multimeter or ohm meter, air circuit breaker, 3-phase, 415 volts, maximum capacity, 400 amperes with instruction manual. Safety precautions. Do not touch any current flowing wires while operating the circuit breakers. All the connections of the circuit breaker should be correct and properly tight. Before connecting the circuit breaker to the supply, provide the earthing by suitable earthing cable necessary. Multimeter. Caution. While using multimeter, select proper mode of selector switch for voltage, current and resistance and also choose proper range. Identify the external parts and control switches of air circuit breaker. Read and verify the specifications of air circuit breaker. Type of circuit breaker: air circuit breaker ACB. Type designation: BS, ES, TS19 ACB RO. Number of phases: poles, 3x3 poles. Rated operated voltage: 415 volts plus or minus 10% AC. Maximum voltage: 660 volts AC. Rated frequency: 50 Hz. Rated current: 400 amperes. Rated symmetrical braking capacity: 2000 amperes. Rated making current: 4400 amperes. Rated short time current: 2 kilo amperes. 1 minute try withstand voltage: 8 kV. Impulse withstand voltage: 12 kV. Type of closing device: AC or DC. Trip free or fixed trip. Trip free. Weight of air circuit breaker in kg: 26 to 30 kgs. Overall dimensions of ACB mounted on frame: 410 mm height, 375 mm depth, 345 mm width. Ambient temperature for which ACB is designed 50 degrees Celsius. Auxiliary voltage for shut trip coils 230 volts. Auxiliary voltage for under voltage release 180 volts. Auxiliary supply voltage for motor drive 415 volts by 3 phase. Identify the external parts and control switches of air circuit breaker. Read and verify the specifications of air circuit breaker. Identify the external parts of air circuit breaker. Off button O. Operations can be switched off through this button. On button I. To get in operation through this on button. Main contact position indicator. Main contact engaged or disengaged indicator. Reset button. Due to any malfunctioning with output circuitry, the ACB will be tripped. After rectification of the fault, to be reset by the ACB by using this button. LED indicators. Status of the ACB. This LED indicators can be indicated. Controller. It indicates and control the functions. User padlock. Parameter can be set through this and it will be logged to avoid unauthorized person. Digital display. The status of the ACB and its meter can be shown in display. Trip reset button. If improperly working, condition frequently tripped ACB can be resulted by this button. Latching or locking mechanism. Connection text and isolated position. It indicates the mechanically position of connection test and isolation. Draw out, draw in hole. The breaker from the panel in proper position. Energy storage status indicator. Energy storage mechanism status indicator. Properly the ACB seated or not will be indicated. Connection test and isolated position indication contacts. It is the connections of the test isolation position indicator respective contacts. Energy storage handle. It is used manually charging handle of ACB. Nameplate. It specifies the details of the ACB such as model working voltage and carrying capacity of the current, etc. Identify the internal parts and control switches of air circuit breaker. Remove the front cover of air circuit breaker and keep the cover in a safe place. Identify the internal parts of air circuit breaker. Sheet steel supporting structure and fixture. It supports all the parts of ACB mounting. Current transformer for protection trip unit. It is abnormal condition which draws more current. It helps to trip the unit. Pole group insulating box. At poles are insulation in this box. Horizontal rate terminals. These are internal linked between plate for fixed arcing contacts and arcing chamber. Plate for fixed main contacts. Contact terminals are fixed on this plate. Plates for fixed arcing contacts. Arcing contacts are mounted on this plate. Plate for main moving contacts. This is moving contact plate. Plates for moving arcing contacts. These are arcing contacts moving plates. Arcing chamber. To avoid more arcing quenching while on or off time in this chamber. Terminal box for fixed version. Sliding contacts for withdrawable version. Protection trip unit. If any abnormal function is happening, this circuit can be protected from more damage. Circuit breaker closing and opening control. It is a mechanism for circuit breaker while opening and closing time. Closing spring. While opening and closing the air circuit breaker from panel, this spring will be activated. Test the manual tripping of air circuit breaker. Conduct the continuity test for the contacts. Remove the arcing chamber from the circuit breaker and test the arc chutes and diverters. Test the working of manual tripping by manual tripping lever. Now connect the main supply to the air circuit breaker and switch on the supply. Observe the condition of indicating lamp and tripping lamp and then charge the circuit breaker manually with the help of an operating handle. Verify the charging of main contact by continuity test. Now verify the disengagement of the contact of the circuit breaker by operating manual tripping switch. Verify the engagement of the contacts by charging the circuit breaker again. Off the main AC switch and disconnect the power supply and fit the cover of the circuit breaker. Recap. In this session, we have learnt the external parts of air circuit breaker, the internal parts of air circuit breaker. Test the manual tripping of air circuit breaker. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.